Welcome to lecture number 13. We're going to start today with a definition. So we have a matrix. The submatrix A sub ij is the matrix composed of the remaining elements of A when the ith row and jth columns are removed. Consider this example. So we have the 3 by 3 matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. A 1, 2 is the matrix composed of removing the first row and the second column. So that's going to be 4, 6, 7, 9. Okay, so now we're ready for the definition of the determinant. The determinant is defined as A11, the first element of A, times the determinant of the submatrix 1, 1, and then you continue along the first row, alternating sign, and multiplying the element of that row times the submatrix formed by deleting that row's column and row number. And this works recursively. Once we get down to 2 by 2 matrices, we use the determinant of the 2 by 2 matrix, which is AD minus BC. So let's compute a determinant. Okay, so we're going to compute the determinant of this matrix up here. And there's a variety of ways of representing the determinant. We can use vertical bars instead of brackets, or we can say DETA, kind of like a function notation. Okay, so we take the first row, and we take the first element of the first row, and we delete its column and row. And so we take that first element and multiply the determinant of the submatrix 5, 6, 8, 9. Then we alternate sign. Take the second element of the first row, which is 2. Delete its column and row. And take the determinant of its submatrix, like so. And then the last column, the last row. Once again, alternating sign. So now we're back to positive sign. And we have 4, 5, 7, 8. Okay, so now we use the definition of the determinant of a 2 by 2 matrix to figure out what those numbers are. This is going to be 1 times 45 minus 48 minus 2 times 36 minus 42 plus 3 times 32 minus 35. And this is negative 3, this is negative 6, and this is 3. Negative 3, excuse me. So we have negative 3 plus 12 minus 9, which is 0. Let's look at the determinant of an even larger matrix, and we'll see why I say that the determinant is defined recursively. So let's compute the determinant of this matrix, which we'll denote with those vertical lines instead of brackets. Okay, so you're going to use the first row. So take that first element in the first row, which is 1, multiply by the submatrix determinant, which is this. And then we have minus 0 times something, plus 0 times something minus 3. I'm not going to fill these matrices in because 0 is going to make them 0. And then the last submatrix is this submatrix. So this is 0, this is 0, and then we use the definition of the determinant of the 3 by 3 to find the determinant of this. So you see how it's recursive. We start with a 4 by 4, we get determinants of 3 by 3s, and then those determinants of 3 by 3s fold into determinants of 2 by 2s. All right, so if we use the first row, first element, we'll get this little submatrix. And note that this determinant is going to be 0. And then we'll have 2 more zeros, which will also produce 0. And then if we use the second element of the first row, that'll be a negative 1, because it's alternating sign. And then we look at this subdeterminant, 0, 1, 3, 1. And the other 2 factors are both 0. So this is 0 minus or plus 3, because the sign gets flipped. 0 minus 3, which is negative 9. And this worked out really nicely because there was lots of zeros. If there hadn't been lots of zeros, this would have been a long calculation.